What did you do?
All right, so I got one solution of 80% alcohol volume.
Okay, and so one solution is 80% alcohol. Okay?
Number 2, 44%.
The other solution is 44% alcohol. Okay? And what's next?
Combined solutions.
Okay? She wants to mix them, right? And obtain
53%.
a new solution,
Values.
which is
53%.
53%, right?
Right.
All right, and then
32 ounces.
Yeah.
The new solution will be 32 ounces.
the new solution will be
32
32
ounces.
ounces. Okay?
How much of each solution is needed?
Okay. How many
Ounces.
ounces of each kind of solution should be mixed, right?
Right.
All right. Now, I already made the diagram or the picture convenient to you. Now, there are two kinds of solution. So let's say how much you need for the first kind. Let's give a variable to represent that if you want to.
X.
You want to say X? So X is what?
Ounces of 80%.
Okay, is the number of ounces of 80% solution. Okay, and then probably Y will be the number of ounces of what? 44% solution. Yes?
Yep.
Okay, what happened? When you mix them together, you will get how many ounces? 32 ounces, right? And you need X ounces for the first kind, Y ounces for the second kind. Am I too fast?
Y equals what? 44%.
Okay. This is 80% solution, and this is 44% solution. Am I correct? And the new solution, the mixture, is 53%, right? Yes? Okay. Now, this is a situation. Now, we would like to see how are they related. How are they related? How are they related? You mix them and you get this. So very, very clear. You mix these two solutions together. So how are they related? Well, the total amount at the end will be 32, and it comes from these two, right?
Yeah.
So here, maybe some of you say, well, Dr. Chen, maybe we can organize what we just, labeled. We say there is the first kind of solution, the first solution. There is a second solution. All right? And there is amount, which is in ounces. There is a concentration, which is using percent. Okay? So how many ounces for the first kind? I don't know. How many for the second kind? I don't know. So I let it X and Y. And then the concentration, the first kind is 80%, right? The second kind is 44%. Is that right? Yes. All right? Okay. Now,
So I'm sorry, just to clarify, so the 80% and then the 40%, they each have their own equation? Or we're at this point, we're just organizing them into a graph?
we organize them, and then we are always curious, what is the pure pure substance. Right now it's a pure what? Alcohol, right? Right now it's a pure alcohol. Am I correct? So how many ounces will be the pure alcohol in the first solution? It will be X times 80%, right? Is that right? Yes?
Wait, why?
Why?
Yeah.
I borrowed this. This is my drink, okay? It's juice. It's 2% juice. And I have 5 ounces. How many ounces will be the pure juice here? Just say 5 ounces, but it's only 2%. It's pure juice. So it will be what? 5 ounces times 2% will be the amount in ounces in this container. Okay? So in the first solution, you have X ounces. Is that right? And 80% out of X ounces will be your pure alcohol. Right? Is that okay? For the second solution, you have Y ounces, and 44% will be your pure alcohol. Right? Is that right?
Because the basic principle here is that constant amount
Times the concentration.
Yeah, amount can be a percentage, or a percentage can be an amount. And
No.
with that theory, you multiply them together.
Percentage is part. Percentage is...
You could say 5% of something, or you could say the amount of something is 5%. I mean, it's the same thing, right?
Oh, so that's why we put a unit. That's why we put a unit. When you say the amount or the quantity, you usually have a unit. Okay? Concentration is in percent, or like 1/3, 2/3, something like that.
But can't you express an amount in a percentage?
Yeah, in conversation, we sometimes talk about...
But it's not based off of that principle, okay?
Okay? All right. So you put an ounce, that's very clear that is in unit of ounces. Okay? Okay, now we would like to figure out what are related. How are they related? So first of all, you have to know the first and the second kind is going to mix together. So you have a mixture, right? So if you want, you can extend this table by one more row, and you would say, hey, there is a mixture, right? How many ounces at the end is your mixture? How many ounces? 32 ounces. Is that right? Is that 32 ounces? Yes. What is the concentration at the end? 53%. So at the end, the mixture would have how many ounces in terms of the pure alcohol? It will be 32 times 53%. Am I correct?
Right. So for the amount of pure alcohol.
Right. That's the amount of pure alcohol. Where is this pure alcohol from? It's from the first container and the second container, right?
Okay.
Is that okay? All right. So now we are going to ask ourselves, what is equal? What is equal? What is equal? Okay? First of all, we say the amount of first solution plus the amount of second solution is the total amount of mixture. Well, which is what? Which is 32, right? They are all in ounces, right? Now, if we focus on the pure alcohol, then you would say, well, in my mixture, I have amount of pure alcohol in the mixture, which is 32 times 53%. And it comes from where? It comes from the pure alcohol pure alcohol from the first solution, and it comes from the pure alcohol from the second solution. Right?
Yes.
I'm not talking about X, Y, Z. I'm just thinking the total amount, if you look at this picture, the total amount adding together, X plus Y, should be 32. Okay? And now I'm focusing on just the alcohol. If I can dye the alcohol by red color, then 80%, there will be a great portion of this will be red. And here, probably just about half, less than half, will be red, right? Altogether, will be the red part here, right? 53% out of 32 ounces are pure alcohol, right? Is that okay? And the pure alcohol, it was from the pure alcohol here and the pure alcohol here. They all mixed together, right? So the pure alcohol here plus the pure alcohol there should be the pure alcohol in the mixture. Is that right? Okay, so what should we write here? So for the first one, you would say X plus Y equal to 32. Is that right? Okay. And then that is to corresponding to this first observation. And then the second observation will be for the alcohol. Then the alcohol from the first container is what?
80%.
Is 80% times X, right? So you say X times 80%. And the pure alcohol from the second container will be Y times 44%. And the alcohol, the pure alcohol in the mixture will be 32 times 53%. We try to translate it. Is that right? Yes? Now we can write it in decimal form. So let's do it. Okay, so this is the system of, this is the model now. And now you can do algebra to solve it. Okay, so X plus Y equal to 32, 0.8X plus 0.44Y equals to, now you multiply 32 with 0.53. Well, so I write it on the side.
16.96.
You already got it. 16.96. Okay. Do I need to solve this together with you? It's okay, right? This is the hardest part, how to set it up. After you set it up, then you can have a freedom to solve it.
I'm sorry, just for review, could you solve that, the two equations, please?
Yeah, I will. I just want to see how many people feel it's hard, but we will do together, so we complete it. Okay, so now would you like to get rid of the decimal first?
Yeah.
So let's multiply the second equation by 100, right? On both sides. So you would have the first equation, still X plus Y equal to 32. The second one will be 80X plus 44Y equals to what? 1696. Is that right? I multiply the second equation by 100, right? Now, do you like to use substitution? Yeah, okay, for this problem, probably substitution is easier. Okay, so from 1, let's call this is 3, and that is 4. So from 3, you can find your x, or you want to get what? X. So x equal to 32 minus y. Substitute that. Substitute it into the fourth equation. Then you get 80 times 32 minus y plus 44y equal to 1696, right? Great, you only have one variable. So now let's continue. So you get what? 2,560 minus 80y plus 44y equal to 1696. So you get negative 36y equals to negative, well, now let's subtract 4 do it on the side so you don't make mistake. A64, right? So what is y? Divide both sides by 36. So what do you get? Divide A64 by 36, you get, what do you get? 24. So y equals to 24. When you get y equal to 24, can you get x?
Yes.
Because x plus 24 equal to 32, right? So x plus 24 equal to 32. So x equals to 8. Okay? At the end, you want to conclude in complete sentences. Okay? What do you say? She needs 8 ounces of 80% solution and 24 ounces of 44% solution. Period. Is it okay? All right. Now let's do next one. Okay. Can I have all of you? Is that okay?
Yep. Yeah, that one
Is that hard?
for sure correct.
Okay.
The hardest part is just translating it.
The hardest part translating.
That is-
Right. Yeah. Okay, let's look at the last problem. What do you know? Okay, can we read out loud first and then we will rewrite it. 1, 2, 3.
John was driving to a conference in Seattle, Washington. During the
First day, he drove at an average speed of 72 miles per hour. On the second day, he drove at an average speed of 80 miles per hour in order to arrive before sundown. He was exhausted after driving such a long distance, 1,148 miles. If his total driving time for 2 days was 15 hours, what was John's driving time for each day? Well, you cannot continuous drive, right? So on each day, he drives a certain amount of time. So the 2 days, it just tells you that it's separate to 2 different portions. All right. On first day, he drove at what speed?
72 miles an hour.
Okay. So was it important to know exactly where he's driving to? No. Okay. So probably I would just start with he drove at 72 miles per hour, right?
first day.
On the first day. Am I correct?
Right.
And then, what do you say? He drove at 80 miles per hour on the second day, right?
Yeah.
For a certain time. Okay? Very good. The total time or total hours,
Total distance.
the total distance. All right, we can start with that. The total distance. Very good. The total distance he traveled was 1,148 miles. Okay, and then the total driving time for both days was 15 hours. What do we want to find? The question sentence is important. Some students don't know what to find sometimes. What to find?
Hours driven on each day. Yeah.
Very good. What was John's driving time for each day? Good. All right. Do you have a clear picture right now? This is a straightforward rewriting. I'm showing you this just to let you know that this will cool yourself down and make you have some organized thought, okay? Some of you may not need this, I know. Some of you already have it here. But I would call this like a tricycle. You know, after some time you can ride on your bicycle. You don't need this, okay? But right now, if you have hard time, try this, okay? Because I believe my students all have the ability to do word problem. Just sometimes their anxiety is too much. Yeah. Okay. So now there are two amount of times on first day and the second day, right? That you need to find. What would you like to set at this point for the variable?
Sigma minus 9x.
He loves to use sigma as a variable. Well,
Now you just use x.
you can use x, okay? What about other people?
A,
A,
B,
B.
C.
Does it matter? It doesn't matter. Okay, it doesn't really matter. Okay, so choose a variable. Since it's about time, you want to use t. All right, so if you say t, t is the what? The number of hours, right? Traveled on the first day. Can we do that? Okay? Is that enough? Yeah? T2. Okay, somebody say, I would like to use T1 and T2. You like to use T1 and T2?
No, that's really confusing.
Oh, okay. Somebody say get dizzy. Okay.
T root 5.
Well, if you want, you can X and Y. You like X and Y?
Yeah.
Okay, all right. It does not really matter. Okay, X and Y. I'm going to help you grow out of X and Y. Okay. On the second day, he spent Y hours. Okay. So what happened? So on the first day, I would say day 1, I try to draw. Oh, he drove 72 miles per hour for X hours. Okay? So when you multiply it together, it will tell you how far he drove. Am I correct? Is that right? That's the day 1, right? Day 2. This is my day 2. Continue driving. Woo, up to here. All right, now this time he is in a hurry. So he drove 80 miles per hour for Y hours. Okay, the speed times the time tells you how far he drove. Am I correct?
Yep.
And altogether, he drove how far? 1,148 miles. Am I correct? Good car. This is a great car. Okay? He drove for the first day up to here, and then from there for the second day up to here. What did you see, my friend? Actually, this explains the whole thing, right? Can you tell me what did you see?
Miles per hour and hours.
Say it again?
No.
Miles what? I heard. No. It's good. It's good. Say it.
I said something I saw in comments, miles per hour and hours. That's all.
Uh-huh.
That's why I said something. Just
Okay.
Word.
That is his speed. Okay? That is your speed. Assuming that you are driving. Okay, so for one day, for the first day, he drove how far? Can you tell me? He drove X hours. So 72 miles per hour is his speed. He drove X hours. How far he drove?
1,140 miles to get
No, on day one, how far he drove? 72 times X. For the second day, he speed up 80 miles per hour. He drove 8 Y hours. So how far he drove? 80 times Y, right? And altogether, he drove this far. So what do you say? You say this plus that equals to this, right?
Do you have to multiply that? Do you have to multiply the last one by 15 hours at any point, or no?
Well, and then we look. Okay.
I'll just wait.
No, you're fine. What is the 15 hours? 15 hours is the total driving time, right? So the first day he drove how far? How many hours? X hours. The second day he drove what? Y hours. So what is the total driving time?
15.
X plus Y. So X plus Y equals to 15. All right, so that comes to the second page. If you try to day 1, day 2, rate times the time equals to distance. Are you with me? Can you see now? Okay, you have 2 days, right? Day 1, what is the rate? 72 miles per hour. Okay, and he drove X hours. Am I correct? So how far he drove? 72 times X, right? The second day, he drove 80 miles per hour for Y hours, right? So how far he drove? 80 times Y. Am I correct? I just try to put it on a table for me to see. You know, some people love to draw a diagram. Some people love to see it in an organized tabular form. It does not really matter. Okay, sometimes you probably would like to do all, just to keep thinking. All right. This is the distance. The distance for the day 1 plus the distance for day 2 will be the total distance. So what do you know? What is equal? What is equal here?
72.
Well, first of all, you know the total distance equals to what? 1,148 miles. Am I correct?
Yeah.
What do you mean by the total distance? Total distance is the distance on day 1 plus the distance on day 2. When you say total, means you add up. Am I correct? All right. What is the second thing you know? Total time. Am I correct? The total time is what? 15 hours. What do you mean by total time? Is the time, the driving time on day 1 plus the driving time on day 2. Right? That's what you mean by total. So the distance, well, these are the distance, right? The distance, when you add together, this is the day 1 distance plus the day 2 distance is 1,148. This is the time for day 1. Y is the hours for day 2. Add together is 15. Now I want you to put down your pen. Okay. I want you to think. Back to this diagram. Maybe some of you can go from here to the system equations already, right? By looking at this, you know, this distance, which is the product of this, plus that distance, which is this product, equals to what? 1,148, right? Total time, what is my time? X hours for the day 1. What is the time for day 2? Y hours. Total time is X hours plus Y hours equals to what? 15. Couldn't you get that right out from this diagram? Yes. You can get this right away. Am I correct?
Yeah.
Some people, they cannot They look at this diagram, they're still confused. Then you say, you know what, I remember maybe I can make a little table, make myself keep thinking, you know? Okay, what is day 1, what is day 2, you know? And then you say, oh, these are the distance. Look at the distance. This is the day 1 distance, that's day 2 distance. Oh, total distance. So you add them together. It will be 1,148. Or some people will try to say, what is the total? They put another column for total. Okay? And they will say, all right, total distance is 1,148. And then the total time is 15 hours. You know? So for some people, they feel like, oh, if I make this as a table, I feel comfortable. You know? Some people like that. And some people say, you know what? I love to talk. I'm thinking, okay, total distance is this, right? Well, this just straight from the problem. Total time is 15. And what do you mean by total distance? What do you mean by total time? Is that clear? This is to ask yourself, what is equal? What is equal? Distance equal to that. Total time equal to that. That's it. Is that okay? I believe all of you can solve this system without any difficulty. Am I correct?
Yes.
We will do it together. 2 minutes. Okay. So what do? Very easy. You see, x plus y equal to 15. I can use substitution, right?
Yep.
Some people say, you know what, Dr. Chen, I love addition method. Can you do addition method?
No.
Let me show you.
I know.
You can multiply both by negative 80 if you want to. Or negative 72. Okay? And then eliminate the y. Okay, so let me put this. If you have 1 minute with me, okay, multiply negative 80 with the second equation. 80 times 15 is what? You don't know? 15 times 80?
15 times.
Okay, it's 1,200. Now, you add them together. You add up the y, you eliminate y, so what do you get? You get negative 8x equals to? What do you get? 52. So what is negative 52, right? I'm sorry, there's a negative sign, I forgot. Okay, so what is x? So x is 52 over 8. And that is, divide by 4, you get what? 2, 13 over 2. So which is 6.5 hours. So the first day he drove 6.5 hours. How about y? Add together should be 15 hours, right? So x plus y should be 15. So that will be 8.5 hours. Okay? Is that okay? Because x plus y equals to 15. All right? So now you can, they ask you what? They ask you the driving time, right? So he drove 6.5 hours on day 1. Am I correct? Anything wrong?
No, can you just repeat how you got the 8.5 hours?
Yes. Because, no problem. Because x plus y equals to 15, right? Is x plus y equal to 15? So what is y? So y is 15 minus x, which is 8.5 hours. Is that okay? All right, so he drove 6.5 hours on day 1 and 8.5 hours on day 2. Okay? Okay.
Oh, I thought it was 65 hours.
6.5. All right? So there will be financial problem, mixture problem, and traveling problem. Okay? And there will be inequality. In 1.4, there will be solving formula for a variable. I will write it on the You know what? Today, some of you told me you have some problem with Canvas. How many of you have some problem with Canvas? Okay, so I will send out email. I'm going to send out an email. I'm telling you for each problem that I'm going to test you, what are the outcomes I'm assessing. Is that okay? So check for your email, okay? Don't just look at your Facebook.
So this is the exam tomorrow?
Sorry?
I said you'll provide what's on the exam tomorrow.
I will tell you, what is going to be assessed tomorrow, okay? But remember, this packet is going to be the format for tomorrow's word problem. Is that clear? And I'm asking, okay, there is a board. Did I pass you this? Okay, I'm going to pass you. I thought that I passed you, no?
The translate phrases.
Okay.
Yeah, well, that's